Okay. Hello and welcome to the Cluster API working group. This is a project under the Cluster Lifecycle SIG. It is Wednesday, April 25th. To start, we have a couple of items on our agenda. Karan, do you want to take the first item? I believe that's yours. I think you're muted.
Yeah, can you hear me now? Cool. So a couple of weeks ago, I presented a proposal for what the tool that Cluster API comes with will look like, and more or less we converged on the experience and the feel for that. We did not converge on the name for it, so I did a vote, and I've linked to the issue for that. clusterctl 1 or cluster control, however you want to pronounce it. Chris was a close second, um, for what it's worth. Um, but I think Tim brought up some interesting questions about uh, planning for a new repo. I know we had discussed to have a new repo for this tool, um, but Tim had questions like, what does release look like? What does testing look like? Who manages it and stuff like that. And honestly, I'm not in a position to answer all of those questions just yet. I haven't um, been able to come up with good enough reasons for one way or the other, except to say that I think it makes sense until cloud-specific providers are split from the main repo. We should keep this tool in the main repo to prevent unnecessary complexity around releasing or vendoring or lockstep releasing and stuff like that.
Okay, does anyone have anything they want to add to that or ask? Tim is here. Do you have anything you want to say with this?
I don't disagree with what you're proposing. I think the original disagreement was to create yet another repo, and I thought that would add way too much extra complexity until we have the logistics worked out. What you're proposing sounds fine to me. I don't have a problem with it. I think to add an extra command, though, as part of the release, you might need to, I don't know who actually controls that anymore. That might be SIG release, or that might be SIG arc. You might need to verify with them before we can do that. But it seems reasonable at this point, either that or to have that tool live with the API proper, because you're still going to have to vendor back and forth. Right? So the vendoring back and forth bit, I think, is going to be the issue until it's stable, right?
Right. I think, yeah, the vendoring the API will still be something we need to be careful about, but we then won't need to worry about at least cloud vendoring, the cloud directories vendoring. For releases, I don't know, is it possible that one of us in the SIG or in the owner's file can just go build and upload the release? Or do we have to serve like a Kubernetes way of doing releases for something this early?
It depends what's the level of support. If it's a first class release artifact as part of Kubernetes proper that will be supported as part of Kubernetes proper, then it would be part of the bundle. If it's not, then it's dealer's choice. And that means the subproject can do what it desires and can release at its own whim and folly. So yeah. Justin's here, the COPS folks release at their own cadence and own interval, right? So that they're a subproject that can do their own thing. So it's up to folks to determine whether or not they want to promote it to be a first class thing as part of Kubernetes that will be incorporated. If so, you probably should make sure that it's at a certain age and stage of when we want to do this. And then it'll be part of the release bundle of Kubernetes proper.
Yeah, I think, this will not be a first class piece of software for Kubernetes, at least for now, at least until it is a little bit more mature. So I think before, when I first create this directory in the repo, I can add instructions or plans for at least some idea of how the release might work and who might be able to do it and what the commands might look like. and then we can iterate as we release every so often on that. And a few months from now, maybe by beta, we have enough information to automate a lot of it. That's honestly my personal vision of this.
Yeah, so for somebody who manages separate projects outside of Kubernetes proper, I absolutely love Go Releaser. And we have our own Travis build artifacts and set up for outside of Kubernetes proper. So some of the stuff we do for Arc and for Sonobuoy and for other things that Heptio products create, it's actually a very nice facility to have the auto CI set up and build and publish the artifacts along with the entire release chain of dev notes and everything else together. It's actually super handy dandy. But that's kind of the benefit of doing it outside the core and being able to manage your own releases.
Right.
You mentioned Go Releaser, and what else did you mention that you're using for CI?
We use Travis.
Oh, Travis, thank you.
We use Travis and Go Releaser for building and bundling and doing all our stuff.
Cool. I will look into both of those. But yeah, I think unless someone has major concerns, we agree on using the same repo and seeing what the release looks like then.
Yeah, and as you mature and as the API matures, nothing prevents you from creating a new repo at a later date.
Right. Exactly.
Any thoughts on that? Any objections from anyone on the call? Looks like we're good then. Thank you.
Yeah, I think as long as everyone is willing to live with it in the repo, then that's probably the best path forward for now. Okay, if there's nothing more on that, the next item is Katie with configurable machine setup for GCE. And I believe this is something Katie has done for the GCE implementation and would like to present it to just get feedback and see what people think. Katie, do you want to take over?
Hi. For those of you who don't know me, I'm Katie. I joined the cluster lifecycle team at Google back in February. So let's get started here. Is this sharing it?
Yes, I can see it.
Okay. All right, so as Chris said, I implemented this for GCE, and this is just kind of presenting the design so we can get feedback on it, any ways to improve it. It's kind of wanted to present it as a suggestion for other cloud providers that could follow this pattern, but it's not going to be like the de facto way we're going to be implementing it. Karan did mention that he was going to switch over his Terraform controller to implement this pattern as well. So to start, I put a link to the design doc in the meeting notes. So if you want to follow along there, you can. Slides are basically just copied and pasted from there. And there's links to the PR that I have that implemented all of this. So the objective here was to modify the GCE actuator so it could handle configurable Kubernetes versions, OS image, and startup scripts. So the way it was before this PR got merged in, the GCE actuator, it would compile a hard-coded script template, which would install Kubernetes on Ubuntu. And so basically, if you wanted to ever change the script, you would have to go into the Go file, change the template, and then recompile and redeploy the entire machine actuator. So that wasn't very user-friendly. You couldn't really change things easily. So we wanted to switch to using a structured config. That would be able.
I think we had a better slide.
Did someone have a question? Or is that?
Yeah, that's yeah.
Okay.
Yeah, mute yourself, please, if you're not presenting.
Okay. All right. Yeah, so the goal is that we could have these configs that would map the Kubernetes versions, the OS image and machine roles to startup scripts that would install these certain things. And this would do a few things for us. We'd be able to support multiple target OSs without having to edit the controller binary. We could use preloaded images, and this way we would just have a separate config that would specify this image, and then the startup script would just skip any of the installation steps. Admins would have a list of vetted setup combinations. The idea here was that we would have a YAML file that would basically list out all the configs. And so then admins would be able to see what we support. And they'd also be able to bring their own OS and machine setup and just be able to add it to this YAML file instead of having to rebuild their own controller. Right. So to achieve all this, I added a few types. They live in this machine setup package here. The base type is the config. So it has a slice of config params, an image, and the metadata. And right now the metadata just contains the startup script. These config params are the OS name, roles, and version info, and these all have corresponding fields in the machine object. So the OS name is specific to GCE also, just to note. But you can think of this config as kind of a key value pair. So these config params are the keys that will map to the specific image and metadata contained in that config. So we'll have multiple of these configs contained in a config list. And the way, whenever you want to spin up a machine, we'll extract the OS, the roles, and the version info out of the machine object to create a params object. And then we'll iterate through these configs and try to find one that has a matching params. And if we find a match, then we know we'll be using that image and metadata for the machine that we're trying to set up. And if we don't find a match, that means we don't support this machine setup, and it would return an error at that point. So this config list is wrapped by valid configs, and this is just a way to abstract these types from outside of the package right now. And this way, the matching is also abstracted. You'll just be using a get image and get metadata methods on the valid configs type. Yeah, and then last type I added was this config watch type. And all it holds is a path to the YAML file that I mentioned earlier. And so this YAML is just the serialized version of these configs. So the way it works is that you would have a config watch. Whenever you wanted to make a new machine, you'd have to call a method called valid configs, which would return a valid configs. Right now, it just looks at the path, grabs the YAML, and parses it out into the configs. One of the future optimizations we could do here, and the reason we set up this config watch, was instead of having to parse the YAML each time we wanted to create a machine and each time we needed to look up a config, we could cache the results and instead just put a file watch on the path. So then we can just continue looking off the cache, and then if the file watch notices that the file changed, then we can just reload the contents at that point instead. Are there any questions about that? Or move on. Okay. So I'm using a config map called machine setup. It's created by the GCP deployer when it's bootstrapping the master machine, or bootstrapping the machine controller. And basically this config map just has the YAML file name machine setup configs.yaml as the key, and then the value is just the serialized YAML, or just the block of text, and then this way it'll just mount that file into the pod. Right now, this config map creation is kind of hidden, and it's a little bit opaque to the user. So this is just kind of a temporary workaround until we can get rid of the GCP deployer. Once we have actual bootstrapping, we can create this config map as part of that process. Yeah, and so then this volume-mounted file is what the master is going to be using whenever it's provisioning new nodes. Okay. For the startup scripts, they're loaded from the config.metadata, but they need some of the information that are in the machine and cluster objects. So currently, I'm just concatenating this template of environment variables to the beginning of startup scripts. This isn't an ideal situation because it limits, it requires the users to have bash startup scripts. So one of the alternatives was to put these values into the GCP metadata, but that would make this extremely GCE like specific. So another alternative was just to have the startup script itself be a Go template, so it could access these values, and then it would just be compiled in that way. And then they can use, they'd have more flexibility in what language they want to write their script in, and it would be more extensible to other cloud providers as well. And so I added a few command line flags, well, one command line flag, one to the machine controller and one to the GCP deployer. And this flag just passes in the YAML file location so that the config watch can be created to look at this file. In the machine controller, it should always be that volume mounted path. And then in the GCP deployer, it's just wherever you saved that file. So some of the future work, as I mentioned, using a better solution for the environment variables for the startup scripts. We want to create or convert the YAML file format to an API type so we can have versioning for it, and then also use the file watcher for the config watch. And I think that's all I have. So if there are any questions about that at all.
Is there a demo?
I can demo it. It basically it's just running the it just runs GCP deployer.
Did you have any plans to convert the contents of the YAML file to like an actual API type stored in etcd?
I think so. We wanted to have it be a version type, and I think that means using a Kubernetes version.
It would get it pretty close, yeah.
Yeah, the idea I think is to have it be very similar to component config for this.
Okay.
I actually don't know. This might take a bit actually to set up. I didn't set it up to do it, but it might work.
Do you guys want to go through a demo right now, or?
I think it might be helpful just to show, the example YAML files that you have, because that's kind of it's a more concrete example of what you just talked about.
Yeah.
You have that already on the screen, so that one is easy.
Is that clear enough for everyone? I don't know if that really helps at all. Yeah, so here's the machine setup configs YAML. This is the one that I added. So here's the list. So starting with the machine params, this is for Ubuntu 16.04 LTS for the master. And then we have all the versions that it supports. So if you wanted to, for example, if your startup script would support multiple Kubernetes versions, you would just create a new, copy this, put another machine params here, and just change the versions to whatever it would support. This image is the full path that you can find it on GCP. And so it's just the image family. It can be a specific custom image if that's what you wanted to use also. And then here's the startup script down here. So the machine's YAML, in the configs, this OS has to match the machine's OS. So this can basically be arbitrary, but for clarity's sake, you could just make it the family name, or if it was like a custom image, you could say Ubuntu 16.04 custom or something like that. So as long as this OS can be found in the configs OS, then that's all good. Here's the versions that it pulls out and also the roles. So these three things together are what gets pulled out to make the machine params when we're searching for the match. Yeah, are there any questions about the YAML files?
So I'm new to this area, but it seems like you're pretty much doing provisioning on the fly, is what it sounds like, because otherwise you wouldn't specify the parameters for some controller to rectify on the back end. Is there a reason why you'd want to support this capability versus saying you explicitly have the other folks bake the images proper with a separate tool, like separation of concerns, right? Because you're basically conflating the notion of a machine along with provisioning of its OS and components.
Sorry, what was that last bit you said?
You're conflating the notion of a machine with the provisioning of its individual components. So like the provisioning aspect is the thing that I'm wondering about, because a machine could be pre-baked, as you mentioned earlier on. This is to provide the ability to do provisioning as part of it.
So I think the idea here was that you could either use like a pre-baked image, but it was just to kind of allow more flexibility in the startup scripts. That was the intention, like why we started these changes in the first place. Just because the way it was before, you had the single startup script that you could use, and you would have to change the controller if you ever wanted to use anything different. So this just allows more customization in that sense.
Yeah, I guess you might have. I think your point, Tim, is it might be more about how the API is structured, or how this object is actually, is actually taking care of both provisioning the infrastructure, right, creating the machine, and also making sure everything, like installing everything if it's not there.
Well, the part that I bristle against is the provisioning of the machine proper. Right?
Do you mean installation of the software on the machine versus provisioning of the VM?
Yes.
Okay, yeah. But I think it's true that this solution would solve both cases. So you could assume that is a empty startup script potentially with a pre-baked image.
Mm-hmm. Yeah, I mean, I'm just wondering, do you want to support this? Because the pieces that you add here in the long term of being able to support these individual components that you want to bake into your image could be computationally expensive and could expand or shrink based upon however people want to make their images, right? It's a wonderland out there. So GCE can do whatever they want to do and control that environment, but Red Hat might want to do custom setup, right?
Yeah.
Or other folks might want to bake in other aspects, right? So it becomes computationally expensive when other tools like Ansible or something work well for doing bits like that, or as long as you have the kicker script on Cloud Init can do whatever it wants to do, right?
Mm-hmm.
I'm just asking questions. You can tell me I'm wrong here, or that you thought about it or whatever.
I'm not entirely sure what you're trying to get at, but the idea of the separation here is that the machine controller takes care of the provisioning of the cloud resource, which is the machine and any network stuff. And then once that is there, we will put whatever's in this metadata into the instance metadata, because that happens upon machine creation too. And it is up to the metadata at that point to hand us back a valid Kubernetes node. And that is, I think, the only contract we really care about, is that they give us a valid Kubernetes node that ostensibly meets the version requirements. Like it can be patched versions or whatever, but ostensibly meets that kind of requirement.
Let me be concrete. What exactly
Okay.
does Docker version 1.12 actually mean in the installation? How is that provisioned? What version of Docker? Where does it come from? What does that mean?
We don't specify how you have to install Docker 1.12, but that is the version that we expect to run with. As you can see from just a few lines below, it calls apt-get install docker.io. It doesn't actually even specify the version in this example.
So, okay, I think that answers my question then. It doesn't look like it's a hard declarative. I'm specifying my Docker, or I'm specifying my runtime is somehow setting up for me. It's all in the startup script below.
Correct. The only thing we will probably do later on is when we actually get the node object back in the Kubernetes API, we may check like the kubelet version is the incorrect version. Like it's reporting, oh, it is 1.9.4. And if, I'm not even sure if it reports container runtime, but we would probably verify that as well.
Yeah, out of curiosity, why do we need to even expose this kind of versions? Why does it matter? I mean, I guess assuming that the operator created an image with whatever versions they decided to create, and as long as it satisfies some APIs from a Kubernetes perspective, why does one has to specify, container runtime versions at the top level?
Mm, So in the machines object, it has these versions specified, and I mean the configs is just kind of like a mapping here between the two.
Yeah, I think this is more of, I guess, a general question. I'm not too familiar with the current set of API, but why are those versions are even part of that API if they are indeed?
Yeah, I'm not like super familiar, I guess, with the machines object. If somebody else could provide input on that.
I believe so this is, more of a question with the machines object and not this mapping. Given that the versions are there, I think having the versions appear in the mapping makes sense because you may need to install a different version of Docker a different way. So you may need a different script or even just point to a different image that already has that version installed. So the question going back to why does this even exist in the machine object? I believe some people expressed interest in being able to control this specific container runtime running on Kubernetes. I'm not sure what the reasons were, but there were like some features that they wanted that weren't supported in certain versions, or maybe they wanted to be able to easily say specify that they want to be able to run both Docker and some other container runtime and be able to switch those off of machines and do like A/B tests or something like that. I'm not entirely certain on what the needs for that was, but being able to lock into certain versions of Docker, I can definitely see being helpful from a just supportability. Like I know all my machines are running on this version of Docker because that's all I support. Given the evolution of this config map, I see how that can be easily just put in here and not have to be specified on the machine when you have because at first we had just the machine as the input and one generic install script that would take the version of Docker from the machine and try to install that version from some apt repo. And this allows more flexibility of just being able to easily support multiple images that are already set up with versions of Docker, or even multiple scripts that are hard coded to install certain versions of Docker. And it may be something we need to revisit.
Yeah, this has also played a role in upgrades, right? So it's kind of it's the the single place where you determine everything that's running as part of that machine or /node, right? And of course for installation, I think it could decouple them and it could have be all provided. When you use that interface, to say, like I want to create a specific component, that's kind of one of the ways to do it, right? That you can have version, kind of a change the version on the object, and the controller reconciles to get that version. If you want to have that fine-grained control over that particular part of the software that you're updating, for example, it could be upgrading just a container runtime and nothing else. And that's kind of, if you take a look at this sort of these other kind of use case as well, it kind of makes sense. It's kind of at least provides an interesting interface there, for customers to use. Not that it's the only way to accomplish that, but I think it kind of it satisfies that property too.
Can I ask sort of I guess a clarifying question? So, I mean, how I imagine this being used is that probably we'll start off with one of these objects with multiple sets of machine params for the different kubelet versions, for example, and that the script would pick that up and install the correct kubelet version. But down the road, we might pre-bake images for each of the different configurations, more like what Tim described, and just be able to very rapidly install exactly the particular combination where we'd only have, in that case, we'd only have one set of machine params and a very short script. Is that sort of the goal? Is that right?
Yeah, I was just separating the concerns. So like I envisioned setting up the VM, pre-baking the image and just referencing the images as any person can bake the images in any way they want to, because there's a million tools to do that. And they set up the stack, right? And then just reference that image versus taking on that domain space.
Yeah, I mean, I think you're always going to need a script, even if it becomes very short. But it is certainly convenient to not have to bake it on every minor kubelet version. I would say, particularly for CI, right? If we want to start doing CI here, where the kubelet version is per PR, or not even per PR, per revision of the PR, then you definitely want. You don't want to. I don't think. I suggest we don't want to bake an AMI per PR or an image per PR.
Yeah, I think that's pretty reasonable for like kind of where this YAML is kind of going in the end.
For what it's worth, we've encountered something. We've done something quite similar to this on the Red Hat side with a solution that we have that's it's working with this API effort as well. Like we integrate sort of, but we have a layer above, and we encountered the similar issue with what we called cluster versions, and they were just pre-baked images where we assume that everything in there is just ready to go, and that's just a node that's going to join the network or the cluster, and if it doesn't, we're going to kill it and replace it. But I can still definitely see the value in potentially injecting a startup script.
Yeah, I think each node is going to need its own metadata just for like self-configuration. Even if like we bake the entire like configuration script into the image, it still needs to pull like a little bit of input, like which cluster am I joining from some sort of metadata, that be it a startup script or some other key in the metadata server that we'll have to populate. So even if the script actually becomes completely empty and we just put like another entry in the metadata, it's like, here's your server and here's a bare minimum access token to start joining it and do your self-verification.
Yeah, that's a good point. I glazed over that part. We do have like user data and launch configs involved right now, and probably ignition soon or something like that. But yeah.
Sorry to derail the whole conversation, but yeah, this conversation was actually very helpful for me to understand. But I think I'm in agreement with Devin and Justin on the potential approaches and uses.
Yeah, Justin brought up a key use of CI. That's something we definitely wanted to support, and we didn't want to hamstring people by forcing them to pre-build every image for every Docker. We wanted to be able to support a variety of use cases, even though for GC and for what we support, we're probably going to go heavily down the pre-baked image route.
Go ahead.
One thing from my side, it seems that, for example, the metadata that is here, like the control plane version or the kubelet version, they can be semantic version ranges. So, for example, this image can support Kubernetes 1.9x or support Docker version 1.12x or something like this, or version between 1.12 and I don't know how they call it, but for example 1.16 or something like this. So I think this is a better approach than just simply hard coding like one single value.
Yeah, right now we just had it as like exact matches, just for simplicity in matching semantics. But I can see the value in like being able to just specify it will support all 1.9.x. But
yeah, one of the other things that this brings us is like if you only give a cluster administrator access to this, but you allow other users to be able to create machines for some reason. If you have an explicit list of versions, like this supports 1.9.4, 1.9.5, and your team hasn't qualified 1.9.6 yet, it can prevent other users from creating 1.9.6 nodes until the cluster administrator updates this and says, okay, yes, we actually support this now. And so that was another use case. But there's definitely ways to just repeat specific point matches, and I think version ranges and version wildcards are reasonable enhancements once we get a little more solid on this. And I would want to have this actually converted into a versioned API type before we start adding stuff like that. Does that sound reasonable? I am either muted or no one cares.
You're not muted. Yeah.
Sounds reasonable. I would like to bring up one thing, which is the bash issue. It is hard to get things robust in bash in my experience. Like the curl has to be wrapped in a retry. Like everything goes wrong. Every single command fails. And I don't know if we can if we can do anything, like what we've tried to do in COPS is try to push people towards like Docker images, but of course we have to get the first thing up. So we have a command that you can run. I just don't, and we have like a horrific bash script with lots of retry logic around curls and all that. And I don't know if we want, like, how we feel about that issue.
So I had mentioned one of the alternatives. You're just concerned about like requiring people to use bash, right?
Just as our tool of preference, it is not a very reliable tool. Yeah.
Yeah. So one of the alternatives to doing the concatenation with the bash thing at the top, if we just move the startup script to be a Go template itself, that way you can see. I can show you. So this is where the environment variables are. So basically there's this metadata params here. So if we just have the startup script be a Go template, they can just use anything in here that they need and just add those as the Go template. And that way they can use a different scripting language if that's what they want to do.
Yeah, I guess the answer to my question is we probably can't do any better, but nothing stops someone baking an image with like Ansible or Chef or their preferred, more reliable tool, or writing a short script. So yeah, I think what you have is good, actually.
I think we shouldn't shy away from trying to do better, because I really don't like that it's forcing us to use bash. Ideally, we would just be able to populate or define some sort of structured parameters to the script and say, here is like a YAML serialization of the structure. Read it however you like, do whatever you want, and make it work.
Yeah, but I mean that's what COPS does. But the bash script basically has a curl to download the magic reliable tool that has retry logic built into it and is written in Go. But I think what's good about this is it lets us figure that out later, and it doesn't, like, some people really want to use Chef on their machines, and we're like, no, you can't really, it doesn't really work. But the bash is a sort of lowest common denominator that leaves it open, and we can write some reliable examples to download Chef, and we can have an example that downloads a reliable tool that parses YAML that is our recommended way.
Okay, were there any other discussion points for this? All right. Thank you, Katie, for presenting that. It was a lot of good information. I don't see any other items on the agenda, so last call for any other points anyone wants to discuss this week. Going once, going twice. All right, and that concludes the meeting. I'm going to stop the recording now.